All right, good morning, everybody. This is TSI Math Crash Course Day 1, Part 1. Today we're going to be focusing on TSI arithmetic mostly. And there's two things that I want to address before we begin the class. So I'm going to teach you two aspects of this test. I'm going to teach you the skills. There's just some basic things you need to know about, like how to deal with decimals and fractions, things like that in class today. The second thing is the strategies of the test, which is really pretty much what I'm going to primarily focus on, is the approach to the questions, a way of looking at the questions that's going to really simplify the test. And the good news for students is that you don't need to know everything about math. You don't need to know everything about arithmetic, for that matter. You just need to know enough to find the right answer choice. And there's kind of a difference there, right? You don't necessarily even have to carry out the exact correct operations to find the right answer. You just need to know enough to be able to eliminate the incorrect answer choices, or just sort of logically and reasonably confirm the right answer choice. Does that make sense, Jackson?
Yes.
Yeah. Okay. Good. So I'm going to start with my rules for TSI mathing. We're gonna focus on two rules today. And for those of you joining us on the recording, we got two students that signed up for the class, and we got one that couldn't make it today. So you're going to hear a lot of Jackson today on the recording. But that's good. He's going to get some good one-on-one attention. Go ahead and read, Jackson, for me, please. Read rule number 1, my rules for TSI math.
Out loud?
Yeah, please.
Okay, use basic logic in elimination and estimation whenever possible.
Yeah, that kind of goes back to what I said earlier. You don't even have to carry out the exact correct operation a lot of the time. Maybe most of the time, right? You can just think logically about things and use some basic estimation skills and figure out what the right answer choice is or what the right answer choices are not and get rid of them, right? Which takes us to rule number 2. Go ahead and read rule number 2 for me, please.
Use process of elimination to test answer choices whenever possible.
Yeah, I really love process of elimination. I'm going to really stress that in the class, throughout the class. And if you do process of elimination, even if you know the right operation, if you're doing process of elimination, you're doing two things. One, you're confirming the right answer choice, but you're also eliminating all the incorrect answer choices. And you can really feel very confident in your answer if you can do both. Does that make sense?
Yes.
Yeah. So we're going to approach that test. We're going to approach the test that way, finding the right answer and eliminating all the incorrect ones. So let's jump right into the questions. And we're starting with some arithmetic questions here. Go ahead and read that first question. Question number 8. You should be able to see it up on your screen.
What is 1,582?
Yeah.
Plus 761.
Okay. I'm guessing, Jackson, you're pretty comfortable with the arithmetic operation here. You know how to add those two. Is that a fair assessment?
Yes.
Yeah, okay, great. We're going to do that here in just a minute. But first, again, I want to follow rule number 1 and rule number 2 using basic logic and just basic estimation. Okay, before we even do the operation. If you were going to guess, just looking at it, what's the correct answer going to be around?
Around like 2,000.
Yeah, 2,000 something. It's got to be over 2,000, right?
Yeah, definitely.
Because even if we were just adding like 500 to this, we'd have something over 2,000.
Yeah.
Right? Look at the answer choices, man. Mm-hmm. Do you see the right answer choice?
Yes, I do.
Yeah. What's the right answer choice?
2,343.
It's got to be answer choice D, right?
Yeah.
Like A, B, and C are silly because those are less than 1,582. Do you see that?
Yes.
I mean, that's crazy. We're not subtracting here. We're adding. The correct answer has to be bigger than 1,582. There's only one answer choice that's bigger than 1,582. Okay? So let's eliminate right off the bat. I want to eliminate answer choice A. I want to eliminate B. I want to eliminate C. It's looking like D. Okay, now look. And it is, right? Let's carry out the operation. Okay, do you know how to add those two numbers together? Now, keep in mind, by the TSI, on some questions, they give you a calculator. It kind of pops up on the screen. Some questions, you don't have access to the calculator. This would be one of the questions I strongly suspect they wouldn't give you access to the calculator on. So let me see you work this out. If you could do it on the whiteboard, that would be great. I just want to kind of carry out the operation here.
Okay.
And let's try to confirm answer choice D, which I think we can do.
write it out.
Yeah, write it out. Exactly how you would solve this. Now, keep in mind too. This is an untimed test. The TSI is untimed, so you got all the time in the world, to work this out. Good. I'd add a little plus sign down here just to avoid any confusion. Yep. So you're just you're lining everything up, adding it all up. 4 plus 8. Yep. Looking good. Looking good. Looking good. And that's it. So we can confirm it. Indeed, it is answer choice D.
Yes.
Any questions about that, Jackson?
No.
Yeah, pretty easy, right?
Mm-hmm.
Okay, good. Doesn't get a whole lot easier than that. But you're going to see some others again that just with basic logic, basic estimation, you're going to be able to figure it out. All right, let's clear this guy and put up the next question. Okay. Okay, it's going to get a little more complicated here. Go ahead and read question number 3 for me, please, Jackson.
What is the value of 4/10 plus 300ths?
Yeah, good. 300ths, I like that. Okay, good. So before we do the operation here, well, first of all, are you familiar with adding fractions?
Yes.
Yeah, right. And you got to find a common denominator when you're adding fractions. We're going to do that in just a minute, but first let's approach this with some basic logic and some just sort of basic estimation. What's 4/10 close to?
5/10.
It's close to 5/10, right? Which is 1/2, right?
Yeah.
So 4/10 is just a little bit less than a half, right? And 3/100ths or 3/100 is pretty small, right? Can we agree that's pretty small?
Yes.
Yeah. And like in decimal form, that would be like 0.03 or something like that. And we'll talk about in just a little bit, talk about turning fractions, decimals, and fractions. It's pretty small. So the correct answer choice is going to be just over 4/10, or we could say probably just under 1/2.
Yeah.
Right? Just kind of feeling that one out. Does that make sense?
Yes, definitely.
Okay. And just because of that, just so we know, the correct answer has got to be something just under 1/2. We should be able to eliminate 2 answer choices that aren't even close to 1/2. What answer choices?
I'd say it could be maybe 7/10.
Are you talking about eliminating or finding the right answer?
Wait, what do you mean?
Well, I want to eliminate incorrect answer choices first. Obviously, incorrect answer choices.
Yeah.
So which ones can we eliminate?
I would eliminate B and D.
Why B and D?
Because they're 110 as a common denominator.
Yeah, that's funky, right? And if you know how fractions work, and this is kind of cool, when you think in logical terms about these questions and answer choices, they're basing a lot of the answer choices on common misconceptions about math. And in this case, a common misconception about how you add fractions, right? You can't just add the denominators together, right? You have to have a common denominator. In fact, and even when you have the common denominator, then you don't add the denominators together. You just add the numerators together, right? So just sort of logically, I agree with you. We can eliminate B because the common denominator is not going to be 110. Gone, right? And then D also the same thing. Common denominator is not going to be 110. But then even more so, that's not even close to 1/2, is it? Answer choice D.
No, it's not.
Yeah, right. I mean, it's like less than 1/10. So that's just kind of silly. Take a look at answer choice C though. I think we can eliminate answer choice C as well. Why can we eliminate C?
Because of the number it is. I don't know if it would be 7/10.
Yeah, well, how big is 7/10? I mean, like, is that bigger than 1/2 or smaller than 1/2?
It's bigger than 1/2.
It's bigger than 1/2.
Yeah.
Right? And there's no way, and we talked about it right off the bat, right? 4/10 plus 3/100. 3/100 is barely anything.
Yeah.
That's just not going to give us anything over 1/2.
Yeah, it's not going to be that great of a tenth.
No. I mean, it's a small hundredth, right? It's just not that big. 3 out of 100 is very, very small. So I think just kind of feeling this one out, again, logic and basic kind of estimation, we can eliminate answer choice C. Okay? Does that make sense?
Yes.
Okay, good. Now, let's do the operation now. Okay, we want to find that common denominator and then add these guys together. So we've got what we've got to do is we've got to express 4/10 with, if we can do it, and I think we can, with 100 in the denominator. How do we do that?
I haven't done it in a while.
Yeah,
so,
no problem. No problem. Do you think you could logically figure it out? And if not, no problem. I'll guide you through it.
I would say you could convert the 10 to a 100th.
Yeah?
But I don't remember how to do it.
Yeah. Well, let me show you how. So, so we got to find the common denominator. The common denominator is going to be 100. Okay? So here's what I'm doing. I'm going to take that 4/10. Okay? And then I'm going to multiply that by 10/10. Okay? Right, with just the parentheses and no sign in between. We're talking about multiplication here, right? Now, Jackson, I got a question for you. What is 10/10? What's 10 divided by 10 equal?
0?
No.
No, 1.
1, right? Anything divided by itself is 1. Yeah. Now, 0 divided by anything is 0.
Yeah.
But anything divided by itself is 1, right? Like 2/2 is 1, and 3/3 is 1, and 10/10 is 1, and anything divided by itself just in general is 1, right? Okay. So when I multiply 4/10 by 10/10, I'm just multiplying by 1, essentially. And what's anything multiplied by 1, Jackson?
Itself.
It's itself.
Same thing.
Exactly. So I'm not changing the value of 4/10 by multiplying by 10/10, right? Because I'm multiplying by 1. I'm just changing the form of 4/10. Does that make sense?
Yes.
Okay, good. All right, so let's multiply this out. Now, do you remember how to multiply fractions?
Yeah.
How do you multiply fractions?
Just, I think the numerators you multiply.
Yep, but not just the numerator. Yep, you multiply both the numerator and the denominator.
Yeah.
Across, right? So I multiply 4 by 10. What do I get when I multiply 4 by 10?
40.
40. And then what's 10 times 10?
100.
100. And now I've got 4/10. Yep, I've got 4/10 expressed with a 100 in the denominator. It's 40/100. But just kind of look at 40/100 for just a minute. Doesn't it just kind of feel like 4/10?
Yeah.
Like it's the same kind of value, right? I mean, it's 40 out of 100. If you get 40 questions right out of a 100-question test, God forbid, wouldn't be great. But that's the same as getting 4/10 of the questions right? It just feels the same. So, and by the way, that's again where if you carried out some operation, I would stop for a minute. You got all the time in the world on the TSI. I'd stop for a minute and kind of just feel things out and be like, does those seem about the same? Yeah, okay, that's about the same. That's the same. Does that make sense?
Yeah.
Okay. And now we're going to add that to 3/100, which we can do now because we've got that common denominator in 100. And now, when we add fractions, how do we add fractions again?
Side by side, I'm not sure. I know how to add fractions. You're gonna add the 3 to the 40.
Yeah.
And then you're not gonna add the denominator.
Exactly. That's it exactly. Yeah. Just add the numerator. Don't worry about leave the denominator the same, which is going to give us 43/100. By the way, you do the same thing when you're subtracting fractions. You just subtract the numerator and leave the denominator the same, as long as you have that common denominator. Okay. Does that make sense?
Yes.
Okay. Well, once again, we've been able to confirm answer choice A, which we got to, by the way, just kind of logically, right? You didn't remember the exact operation of carrying out fractions. Doesn't matter. You would have gotten this one right if you thought about it logically the way we were thinking about it. Does that make sense?
Yeah.
How awesome is that?
It's really good.
You just don't need to know everything. And it's a totally different way of looking at tests. I approach the SAT and the ACT the exact same way. You don't need to know everything about math. You just need to know enough to find the right answer choice. There's only 4 answer choices. There's 5 on that. There's 4 on the ACT math as well. You just don't need to know everything. Just enough to find the right answer choice, and we've got enough to find answer choice A here. Okay. Any questions about that?
No, sir.
Okay. Rock and roll. Let's keep going. These questions, by the way, are taken from the College Board website. They go over some AccuPlacer questions, so these are the kind of questions you might see at some point on that TSI. All right, so we're dealing with some more fractions here. All right, go ahead and read question number 19 for me, please, Jackson.
Which of the following inequalities is true?
Okay, you know what an inequality is?
I think so.
Yeah, I mean, it's kind of like, do you know how to read inequalities?
Yes.
Okay. Like, let's just talk about inequality for just a minute. Let's take answer choice A. We got to find which inequality is true. And let's take answer choice A. How would you read answer choice A? This guy right here.
3/4 is greater than 5/7.
It's actually the opposite. We'd read that as 3/4 is less than 5/7. And this takes me back to like middle school, maybe like elementary math. This is how I learned it, and it's always stuck with me. Okay, if I've got an inequality, and I don't know whether this one's true or not, I'm just going to write it out. Okay, but I've got an inequality like 3/4 is less than 5/7. Here's how I learned it as a student. It's just always stuck with me. I turn the inequality sign into a Pac-Man. Right? You played Pac-Man before?
Yeah.
Maybe not. I love me some Pac-Man. Pac-Man wants to eat the bigger number. Right? He doesn't want smaller. He wants a bigger number. So we could read this as 5/7 is greater than 3/4, or 3/4 is less than 5/7. But the mouth of the Pac-Man is always going to be directed toward the bigger number. Does that make sense?
Yeah.
Just an easy little trick to remember. That if you literally need to redraw these with a Pac-Man, do it. I'm 100% cool with that, dude. 100% cool with it. Does that make sense?
Yeah.
Okay. All right. So 3/4 is greater than, 5/7 is greater than 3/4. 3/4 is less than 5/7. Now, do you know whether 3/4 is less than 5/7?
I would say it's greater than. It looks like it is.
Yeah, it's close, man. That's close. That's tough to, like, potentially. And maybe this is something worth doing. Is let's make this concrete. Like I would love to take two rectangles. In fact, I'm going to do that. I'm going to make two rectangles here. Something like the same size. Okay. Use that little rectangle function. And let's divide up that first rectangle into 4 parts. Okay. And I'll take care of that on the whiteboard. So I'm done into 4 parts. So I'm going to split it in half first. Ooh, that was not pretty. Split it in half. That's pretty good. Think about that first rectangle divided into 4 parts, right? Does that make sense? And then 3 of those parts are going to be shaded in, right? 3 of those parts are going to be shaded in, so it'll be like something like that. Okay. Those parts are shaded in. Okay. And then 5/7. Ooh, this is going to be tricky. I'm going to try to divide this into 7 parts. This is an undertaking. Okay, something like 1, 2, 3, 4. That's more like 6. Hold on. 1, 2, 3, 4, 5, 6, 7. Okay, something like that. Okay. And then 5/7 is going to be something like this. That's close, right?
Right.
I can't eliminate that, just logically. I can't eliminate or confirm it. Okay? But that's the approach, right? Is to make it concrete. Again, I'm trying to use basic logic and basic estimation here. Does that make sense? Those are close. Let's try answer choice B. Go ahead and read. So we'll leave answer choice A. Read answer choice B for me, please.
2/3 is greater than 5/6.
Okay, is 2/3 greater than 5/6?
I think they might be equal or something. They're like, I'm not sure.
Well, let's do the same thing with the rectangles. All right. Two rectangles, something like equal size. Let me make the other one a little bit longer. Okay, that's pretty good. All right, so let's split that guy into 3 parts. The first guy, that'll be represent 2/3. That's pretty good. And then 5/6, I'm going to cut that in half first, and then it's going to give us something like 6 equal parts there. Okay, can you do me a favor, Jackson? Go ahead and shade in that 2/3 for me, please. Do you know how to do that? So we're going to take this. This is the 2/3 fraction. Yeah, exactly, right? This is going to be the 5/6 fraction. And then shade in that 5/6 fraction. So we got to shade 5 out of the 6 rectangles within that rectangle. Yeah, almost all of them except that last one. Which one's bigger? Which one's a bigger fraction?
5/6.
Yeah, 5/6 clearly.
Yeah.
That's pretty easy, right?
Yeah.
Does that make sense?
Yes, it does.
Yeah, like we're not even carrying out a mathematical operation here, really. We're just trying to think in concrete terms. I really, really strongly recommend that. I'm going to show you the operations to be able to basically you're going to express the fractions in with the common denominator, and then you'll be able to compare the numerators. But just kind of think about it logically. I think we can eliminate B pretty easily. What about answer choice C? How would you read that?
5/8 is greater than 6/10.
All right, is 5/8 greater than 6/10?
Okay, I'm not. Let's check.
Let's check. You want to do the triangle, the rectangle thing?
Yes.
All right, let's do that. 2 rectangles. Essentially equal area, roughly. And then we'll split that guy into 8 equal parts, the first one. So split in half, and then 4 parts within that. That's 8, and then this is going to be 10. Ooh. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. All right, so let's shade in 5 of the 8. Go ahead and do that for me, please.
Yes.
Okay. And then shade in 6 of the 10 for me. That's close too, isn't it?
Yeah, it really is.
And this is where we got to be careful, right? Because we don't know exactly, this is not perfectly drawn and measured out or anything like that. If you had a ruler handy or something like that, it might be easier to be a little more precise about it. But this is close, right? I don't want to eliminate it. Not yet. Okay? Not yet. So let's leave it. But let's look at answer choice D. Go ahead and read that for me.
4/5 is less than 2/9, or 2/9 is less than 4. Is greater than 4/5.
Yeah, 2/9 is greater than 4/5, or 4/5 is less than 2/9. Well, let's do this one with rectangle. I think this one's going to be a little more straightforward. By the way, just looking at those, do you know which one's bigger?
4/5.
4/5, yeah, it's probably going to be big. Just looking at it, you should be able to figure. But let's confirm it using the rectangle method. I'll take that, I'll split it into 5 parts. 1, 2, 3, 4, 5, and then 2/9. Ooh, that's going to be tricky, but we'll get it. 1, 2, 3, 4, 5, 6, 7, 8. I'll just make it L there. That'll work, okay. And then go ahead and shade in that 4/5. Yep, and then 2/9. Looking good. Okay, which one's bigger? Come on, this is easy, right?
4/5.
Yeah, 4/5 is clearly bigger than the 2/9, right? So we can eliminate answer choice D? Right? Okay. Now, let's stop. If this is as far as you get, okay, and you can't remember the exact operation when you take this test, I'm cool with that. You got a 50-50 shot on a problem that's not super easy if you're not super comfortable with fractions. And those are pretty good odds, right? We're talking like flipping a coin. Right?
Right.
Good. I mean, it's better than like being like, man, I don't know how to deal with fractions, just picking something randomly. You got a 1 in 4 chance of getting it. But if you think about it logically, use some basic estimation, if all you do is eliminate half the incorrect answer choice on this test, you're going to know how to solve some of them. You're going to really succeed on the test. If on the trickier problems you don't know how to solve, you can eliminate half the incorrect answer choices. You're going to succeed on this. Does that make sense?
Yes.
Okay, good. Now, if you're going to guess whether it's A or C, which one would you go with? Which one's a true statement?
Wait, let me think. Probably.
I mean, just it can be even just random.
I'm not sure.
Yeah, okay. That's it. Well, let's do some math here. Let's do some math. And here's how we're going to find out which one is the bigger fraction. We need to express each of these inequalities, each of the fractions here, we'll start with the answer choice A, with a common denominator. Okay? How do you find a common denominator again? Do you remember how to do that?
Yes.
Yeah. Okay, so what's the common denominator going to be for answer choice A?
For A,
Mm-hmm.
it's going to be like 21.
Well, let me teach you a little trick for common denominators. You may not find the lowest common denominator. The lowest common denominator is always kind of ideal. You may not find the lowest common denominator, but you will always find a common denominator if you just multiply the denominators. And what's 4 times 7?
28.
4 times 7 is 28. So let's make 28 the common denominator. It'll work. It'll work. It'll always work. May not be the lowest common denominator, but it'll be a common denominator, and that's good enough for us. Does that make sense?
Yes.
So let's make 28 the denominator. How would we express 3/4 with a 28 in the denominator?
Would it be 12 28s?
Well, let's do that trick. I'm not sure. I'm not sure.
Yeah.
Let's do that trick that I taught you earlier, right? Where we multiply it by some form of 1. And what are we going to multiply by 3/4 by in order to get a 28 in the denominator? Well, what do we have to multiply 4 by to get a 28 in the denominator?
You have to multiply 4 by 7.
4 by 7. So what's going to have to be in the numerator?
7.
7. Right? Because 7 divided by 7 is 1. We can't change the value of 3/4. Right?
Right.
We just want to change the form of 3/4. So now all we got to do is just multiply these fractions. So what's 7 over 7 times 3/4? Let's just multiply across the numerator. What's 7 times 3?
21.
21. And then 7 times 4, of course, is 28, which is why we chose to multiply by 7 over 7. Does that make sense why those two fractions are equal? 3/4 and 21 over 28. Does that make sense?
Yes.
Okay, good. All right, so that is less than, according to answer choice A, and we'll find out if it is or not, less than 5 over 7. And how do we express 5 over 7 with the 28 in the denominator?
So you would multiply it by 4 over 4?
Exactly. Great job, Jackson. You're catching on, buddy. Multiply by 4 over 4. And what does that give us?
20 over 28.
20 over 28. Ooh, those are close. Aren't they close?
Yeah.
Ooh. No wonder it was so hard to estimate that. They're very, very close. By the way, which one's bigger?
3/4.
3/4 there is big, right? 20 over 28, obviously bigger. So that's not a true statement. Does that make sense?
Yeah.
Yeah, okay, so we can eliminate answer choice A. Gone. Adios. Okay. Let's look at, I'm going to clear a little space on the whiteboard here. Let's look at answer choice C. Again, we want to, look, answer choice C is looking good. Okay. But remember, we want to eliminate the incorrect answer choices and confirm the right answer choice just to know we're on the right track. And we can be really confident in our answer if we can do both. So how would we express 5/8 and 6/10 with a common denominator? Well, first, what's their common denominator going to be?
80.
80, yeah, right. Again, if you want to find a common denominator, it may not be the lowest common denominator, but a common denominator, just multiply the denominators. So how would we express 5/8 with an 80 in the denominator?
It'd be
What?
50/80ths.
Yeah, what are we going to multiply by?
10 over 10.
10 over 10, exactly. So 10 over 10 is 1. We're not changing the value of 5/8, we're just changing the form. And what does that give us when we multiply that?
50/80ths.
50, yeah, 50 over 80. It's probably how but yeah, you're right, 50/80ths. 50 over 80. And then how do we express 6 with an 80 in the denominator? We've got to multiply by what?
8 over 8.
8 over 8. Okay. Ugly looking 8 there. There we go. That'll work. And then, so let's multiply across the numerator and denominator. What's 6 times 8?
48 over 80.
Yeah, 6 times 8 is 48 over 80. Also close. Huh?
Yeah,
Really close.
really close.
But which one's bigger?
5/8.
5/8 is bigger, so we can confirm it is indeed answer choice C. Any questions about that?
No, sir.
Okay, great. But again, and that is a specific operation, and that's not super easy if you're not super familiar with fractions. It's probably been a while since you've done operations with fractions. It's probably been since like middle school, where you've like really studied it closely. And but you don't even need, you can at least eliminate answer choice B and D using some basic estimation. You got a good chance of just getting it right because you're thinking strategically. Does that make sense, Jackson?
Yes.
Great. Okay. All right, let's clear this. Dividing fractions. Go ahead and read question number 18 for me, please.
If 4/3 divided by 1/6 equals P, then the value of P is between which of the following pairs of numbers?
Yeah, here you're just going to have to know the operation here, I think. Because, like, a lot of times we can do some, like, basic estimation. We're talking about addition or subtraction or multiplication. Dividing by a fraction, that's just tricky to conceptualize. 4/3 divided into sixths. It's going to be tough to estimate. So let's carry out the operation. There's a very specific operation when we're dividing by fractions. Do you remember, Jackson, how to divide by fractions?
It's really, really distant.
Yeah. You got to multiply by something. You got to turn it to multiplication.
By reciprocal, right?
Multiply by the reciprocal. Yeah, so we're going to multiply 4/3 by the reciprocal of 1/6. And what's the reciprocal of 1/6, Jackson?
6 over 1.
6 over 1. So multiply that guy by 6 over 1. Okay, now, a couple things here. We've talked about multiplying with fractions. You can just multiply across the numerator, multiply across the denominator, and that's fine. We can do that. Or we can also maybe cancel some stuff out before we multiply, which is generally what I recommend if you're familiar with that operation. Do you know how to cancel things out?
Yes.
Yeah. What can we cancel out here?
6.
Yeah, the 6 and the what?
3.
Yeah, and what does the 6 become?
2.
Yeah.
I mean 3.
No. You're right. It's 2, right? 6 divided by 3, and 6 is in the numerator, and divided by 3 is just going to be 2. So we're left with a 2 in the numerator.
Yeah.
Does that make sense?
Yes.
Okay, we can do that. I mean, another way to look at it is, we can express 6 in terms of its factors, right? 6 is the same as 2 times 3. And look, we got something in the numerator. We got a 3 in the numerator and a 3 in the denominator. We can cancel them out, and we're just left with 2 in the numerator. That's another way of looking at it. Or you can just be like, all right, 6 divided by 3 is 2, so it's just 2. Either way, it doesn't really matter, okay? Which is going to give us what?
4 times 2 is going to give you 8.
8 divided by 1, which is just regular 8.
Yeah.
Okay, does that make sense?
Yes.
All right, what's the right answer choice then, buddy?
C. No, I mean D.
Yeah, it is. Yeah, 8 is between 8 is between 7 and 9. It is answer choice. Answer choice D. So here's an example of a question where you really do have to know the specific operation. Okay, and remember that when you divide by fractions, just multiplying by the reciprocal.
Okay.
Really useful operations, and especially useful, we start talking about like isolating variables and algebraic equations with fractions and stuff like that. You got to know that operation. So remember that one. I knew it was somewhere in the back of your head. Everybody learned it at some point. But when you divide by fractions, you just multiply by the reciprocal. That's good enough for me. Okay. Any questions about that one?
No.
Okay. Let's keep going. All right, that was dividing fractions. Let's do fractions of a whole. This is interesting. Go ahead and read question number 20 for me, please.
Carol works at a bookstore and a restaurant. In a 28-day period, Carol worked 1/4 of the days at the bookstore.
All right, stop. I'm going to stop you. I love, on word problems, I love using this strategy. When they give you a chunk of information, okay, ask yourself, what can I solve for with that chunk? Okay, so they just said in the problem, in a 28-day period, Carol worked 1/4 of the days at the bookstore. Okay, how many days did she work at the bookstore? Do you think we could calculate that?
28 days.
Well, during the 28-day period, she worked 1/4 of those 28 days at the bookstore.
Oh yeah.
Right. So how many days did she work at the bookstore? Do you understand my question?
Yes. 28 days divided by 1/4. Like what's 1/4 of 28 days?
Well, that's my question, right? What's 1/4 of 28 days? What's 1/4 of 28 days? Could you figure that out logically without doing an operation? And maybe not.
4 times 7. So 7 is 1/4?
Yeah, 7, right? Does that feel right? 7 days would be 1/4 of 28. Does that make sense?
Yes.
Absolutely. Right? I love again, just basic logic here. If we said she worked half of her days at the bookstore, it's just, half of 28 is 14. Right? And 1/4 is just going to be another half of that.
Yeah.
So 14 divided by 2, that's 7. So she worked 7 days at the bookstore. Okay? Now here's the operation. Right? If we're going to find some fraction of a whole, in this case they want you to find 1/4 of 28. We'll just take 28, or 28 over 1, it's the same thing, and multiply by 1/4. Right? That of, she works 1/4 of the days at the bookstore. Of basically means multiplication here. Right? If we're talking about 1/4 of 28, multiply 28 by 1/4. If we're talking about 1/3 of 28, multiply 28 by 1/3. If we're talking about 1/10 of 28, you multiply 28 by 1/10. If we're talking about some fraction of a whole, just multiply the fraction by the whole. Does that make sense?
Yes.
Okay, great. All right, and so that gives us, that would give us 28 over 4, which is just 7. Or again, we can cancel things out here, but let's just multiply across. I think that's easier here. 7 days, and that's the operation. Does that make sense, Jackson?
Mm-hmm.
Questions? Any questions so far?
No.
Okay. Now notice, I don't even know what they're asking us to solve for right now. Okay? We haven't even gotten to that point yet. They always tell you, what you're solving for at the last sentence of the question. We're not that far yet. But I can guarantee, whenever they gave you a chunk of information like they gave us here, we're going to need to use that chunk to solve for, to solve for something that's going to be necessary to find the right answer. Notice, by the way, the answer isn't 7 days, because 7 days is the days she worked at the bookstore, but they're not asking us about how many days she worked at the bookstore. We'll find out what that is in a minute, but we're going to need to know how many days she worked at the bookstore to solve what they're asking us to solve for. Okay, let's keep going. So she worked 1/4 of the days at the bookstore, that's 7 days, and then she didn't work 1/14 of the days. Yikes! Well, how many days didn't she work, right? That's the next thing we can solve for. How many days did she not work?
1/14 of the days. Okay, so
how do we find 1/14? It's 1/14 of 28 days, right? How do we find 1/14 of 28 days?
Okay, so 14 is half of 28.
Yeah.
So
could you feel it out? Sort of like just
she didn't work 1 day.
That would be 1/28 of the days.
Yeah.
That'd be 1/20th days. Well, and here's the operation. Remember, we just said this, right? If she's working 1/4 of the days at the bookstore, we multiply 28 by 1/4. And if we want to find out how many of the 28 days she didn't work, that's 1/14th of the days. All we got to do is multiply 28 by 1/14th, which gives us what?
28 over 14.
Yeah, which is what? What's 28 divided by 14?
It's going to be 28 divided by 14.
Yeah.
Is going to be 14 used in 28 2 times.
Yeah.
So.
Yeah. So it's 2.
Half.
It's 2. No.
Okay.
It's 2. It's 2. Right? 14 divided by 28. Right? 14 is bigger, or your 28 is bigger than 14. It's twice as big. So 20 divided by 14 is 2. So she's not working 2 of the days. Does that make sense?
I guess.
That didn't sound super confident there, Jackson. It's tricky because 1/4, like the 1/14th is a little more complicated fraction. I mean, you understood why if she worked 1/4 of the days at the bookstore, that's 7 days at the bookstore.
Yes. Yeah.
Now, if she didn't work, let's say she didn't work 1 out of the 28 days. Right? That would be 1 day. Right? Because it's 28 times over 1 times 1/28. But
would you be able to solve it by just changing the denominator to 28?
Yeah, you could probably do that. Yeah, absolutely, right? And that's maybe even a better way to look at it. I like that, dude. I like that. I'm thinking in terms of like the operation here, but I love it. You're right. You're 100% right. We could express 1/14th with a 28 in the denominator, and what's that going to be?
2 28.
Yeah, 1/14th equals literally 2 out of 28. So she didn't work 2 out of the 28 days. Does that make sense?
Yes.
I'll take that. I like that. I'm down with whatever works and whatever makes sense. In case it's not obvious, by the way, there's a lot of ways to approach these questions and a lot of ways to understand these values. Lots of different ways.
Uh-huh.
So do whatever works for you. But you're absolutely right. Yeah, 2 out of 28. 2 out of 28 days. She's not working. Does that make sense so far?
Yes.
Okay. So all we've done, by the way, again, like all we've done at this point is we've taken the chunks of information they've given us in that first sentence, and we said, okay, what can we solve for with that information? Right? And we've determined, okay, she's working 7 days at the bookstore. She's not working 2 of these days out of the 28-day period.
Mm-hmm.
Okay. Keep reading, please.
Okay. On the remaining days, Carol worked at the restaurant. How many days did Carol work at the restaurant during the 28-day period?
Okay. How many days did Carol work at the restaurant during the 28-day period? Okay, she worked at the remaining days, right? The days she wasn't working at the bookstore, and the days she wasn't working, she was working at the restaurant. So how many days was she working at the restaurant?
Well, we know that she worked there 7 days.
At the bookstore, not at the restaurant.
Oh, at the restaurant.
Yeah, they're asking us. And sometimes on word problems, I recommend students underline the last sentence of the question so you make sure you know what we're solving for. How many days did Carol work at the restaurant?
Well, if she worked 1/4 of the days at the bookstore, could we say that she worked 3/4 at the restaurant? Well,
you were close, almost 3/4, right? Because she didn't work 2 of those days, 2 of the 28. So you're right. The answer is going to be close to 3/4 of 28. And maybe that's a better way of looking at it.
Yeah.
Which answer choice is close to 3/4 of 28? Just look at the answer choices. I mean, 3/4 is bigger than 1/2, right?
Right.
So we can eliminate 2 of the answer choices that are clearly not bigger than
21. So close to 21.
Yeah. What answer choice is close to 21?
19.
19. There's your answer.
It looks close.
That's your answer, man. That's the answer. That's the answer. Just like, I like the way you approached it better than I did. Right? Where you're just like, well, she basically worked 3/4 of the days at the restaurant, which is basically correct. It's close to that. I know she didn't work 2 of the days at all. Now we can confirm it with the math, right? I mean, because we solve for this stuff here, that she's working the bookstore for 7 days, she's not working 2 of the days. That means of the 28 days, the remaining 28 days, so I just subtract the 7 and subtract the 2 from 28. 28 minus 7 is 21, minus 2 is 19.
Oh, wow.
Does that make sense?
Yes.
Which is why if you can solve for this stuff up here, you're very close to finding the right answer.
Yeah.
But I think I like the way you approach it better, just kind of feeling it out and estimating, right? You're like, okay, she worked like 3/4 of the days. It's close to that at the restaurant. Which one's close to 3/4? It's just 19. The others are too far. 25 days? Nah.
No.
That's too much, man. And then the others are less than half of 28. She's not working less than half than 28 days at the restaurant. She's working the majority of those 28 days. Over half. Does that make sense? How, like, you don't even again, you didn't even have to know the right operation here.
Yeah.
I wanted to go over the operation with you, but you can just kind of feel this one and think about it logically. Remember, especially for word problems, these are all real-world questions with real-world solutions. So the correct answer has to be reasonable. You can just feel it out.
Yeah.
Okay? It's concrete, man. Make it concrete. Don't see, and this is where it's different from like most math tests you've ever taken. Most math tests are like, okay, what is the right steps and all the operations? Right? There's 7 steps in this problem. You know, they're like, okay, I'll try to do all the steps, 7 steps and not make a mistake. You know, and it's like, you just don't have to approach it like that. You'd be like, well, okay, it's more than half, so it's got to be A or B, and A's too big. So it's B, which it is.
Yeah.
Good enough for me. You get a feel for how to approach this test now?
Yes, definitely.
Is it different from how you've been approaching your, math classes?
Yeah, I think so, because I've definitely been looking at my math work.
Yeah.
For like the actual formulas.
Yeah. And you know what, for your math class, you probably have to. But for the TSI, and for that matter, the SAT and ACT, you don't have to. The more I teach these tests, the more I'm telling students, it's not a math test, it's a logic test. It's a logic test.
And if you combine like the logic with the math formulas,
you're golden. Exactly.
You're going to do really well.
You're already, you get it. Okay. Go to question number 11 for me, please.
Okay. Which of the following is equivalent to 8/25?
8/25, okay. Yeah, 8 over 25, 8/25. Woo, 8/25. Okay, 8/25 is that's close to what fraction?
I don't see it.
How many times is 8 going to 25?
Wait, actually.
Just feel this one out.
It goes into 25 3 times.
3 times, right? It goes into 24 3 times perfectly.
Hmm.
Right? Perfectly. Like 8/24 should be a third. Right? So this is just going to be a little bit smaller than a third. Just a little bit smaller than a third. Does that make sense? Yes or no?
Yes.
Okay. Do you know how to express a third as a decimal?
No.
No? You don't know 1 divided by 3?
0.3.03.
Is it going to be 0.3 or 0.03?
0.03?
No. No. No, think about if we got 1/3, and then obviously if we multiply a third by 3, we get 1, right?
Right.
So because 3 over 1 times 1 over 3 is just 1. Anything multiplied by its reciprocal is 1. So for the correct answer choice, let's say you think I think it's 0.3. Well, multiply that by 3, and what do you get? You don't get 1. What do you get when you multiply 0.03 by 3?
0.03 by 3, you get 3? Like, I don't know.
Yeah, you'd get a 0.9.
0.9.
0.9. Or sorry, no, 0.09. I apologize. 0.09. 0.09. And we're going to go over multiplying decimals here in a little bit, and adding them for that matter. Another way to look at it is like just instead of carrying out the multiplication, add them up 3 times. It's the same as multiplying by 3.
Mm-hmm.
And so just go down 3 plus 3 plus 3 is 9. So 0.09 if you're adding. Ooh. Does that make sense?
Yes.
Okay. So that's not super close to 1. Does that make sense?
Yeah.
Okay.
So it's not going to be A.
It's not going to be A.
No.
It's not going to be A. That's way too small. And think about that for a minute. Like 0.02, like we could multiply that by 10, and we wouldn't even get anything bigger than 1. Right?
Right.
Like what's 0.02 times 10?
0.02 times 10?
Yeah. You just move the decimal. You just move the decimal over, basically.
Move the decimal to. So 0.002.
Well, that would be making it smaller.
0.2.
0.2.
Yeah. 0.2.
Right. And if we multiply 8 over 25 by 10, we're going to get something bigger than 1. Right. If it's like close to a third. So I agree. Answer is A is too small. Does that make sense?
Yes.
Okay. What about answer choice B?
I don't know.
And if you don't know, that's okay. Let's leave it. What about answer choice C?
Well, I see both of the numbers in this one.
Yeah. You do. But I want to think in terms of the values. I want to think in terms of the values. Okay? Is a third, or 8 over 25, is that close to 0.825? Is 0.825 bigger than half or less than half?
It's less than half.
No. 0.5 would be half.
It'd be bigger than half?
Oh, yeah. 0.5 is half. 1 divided by 2 is 0.5. And 0.825, that's close to 1. Right? Like 0.9 would be close to 1. 0.8 is pretty close to 1. 0.825 is close to 1. It's definitely bigger than 0.5.
Okay.
I'm guessing here you're not super comfortable with like the values of decimals. Is that a fair?
No.
Let's do this. Let's think in terms of, here you go. Let's think in terms of money. Money! Dude, money! Let's make this concrete. Right?
Right.
0.02. That's 2 cents, man.
2 cents.
That's 2 cents. 0.32. That's 32 cents. Right?
Yeah.
0.82. 83 cents. I'm going to round up. Right? That's $3.13. Rounding up again. Why not? Does that make more sense? Those values make more sense now.
Definitely.
It's money. Right? Come on. Is 83 cents more than 50 cents?
Yeah.
Yeah. Almost $1. Not quite.
Almost $1.
Right?
Right.
Is 32 cents, is that close to a third of $1?
Yes.
Sure is.
Yes.
Right?
Definitely.
See, you know this stuff.
75 cents. Right.
Yeah. You know this stuff, man. You just didn't realize you knew it.
Yeah.
Gotta make it concrete.
I do. So I would say that C is the closest.
C is the closest to a third of a dollar?
Yes.
I wouldn't say so. Remember, look, what's a third of a dollar going to be? I mean, a third is less than half, right?
Oh, a third.
A third. Right? 8/25 is close to a third, right? We established that, I thought.
Yeah.
So it's got to be less than half of a dollar. And because we know it's got to be less than half of a dollar.
B.
Yeah, look, because it's less than half, we know we can eliminate what answer choices that are not less than half of a dollar.
So then we know that B is going to be smaller than a half of a dollar.
Yes, it is. So is A, but A is too small. 2 cents isn't a third. 2 cents is not a third of a dollar. Right.
Mm-hmm.
But look at answer choice C. I mean, that's bigger than half.
It's way bigger.
Way bigger than half. Look at D. Right? That's not a third of a dollar. That's 3 times a dollar. Answer choice B.
It's B. Yeah.
Which is what we said. 1/3. If you punch that into a calculator, you get 0.333333333 per infinity.
Wow.
And we said 8/25 is just a little bit less than a third, which it is. Is this making sense now?
Yes.
Okay, good. We had to make it concrete. But again, that's the name of the game. Making these things concrete. Actual values that have meaning. Right? Get out of the world of theory. The world of theory is boring. It's just annoying. And we're like, what is the right operation here? It's like, okay, how much is this value? 0.02 is 2 cents. 0.32 is 32 cents. Okay? All right. Let's do a couple more, then we'll take a little break coming up here. Which one is that? That was... least to greatest. Ooh. Yeah, let's do this one. Okay. Good. This is exactly what we were talking about earlier. Okay, go ahead and read question number 6 for me, please.
Okay, what number in the list above has the greatest value?
Is the greatest value. Ooh. Okay. I would rather approach this by eliminating the ones that I know are not the greatest. Process of elimination. Can we do that?
Yeah.
Which one? And by the way, think in terms of money again if you want to. Please do.
Yeah.
Which one is not the greatest?
Obviously 19 cents.
Yeah, gone. Come on, man. Come on.
Out of here.
That's not as big as $2.28. Come on. What else can we eliminate?
I'm not sure because 10/12 is pretty big.
Is 10/12 bigger than 1 or smaller than 1, Jackson?
It's smaller than 1.
It's smaller than 1.
We can eliminate that.
Easily, right? Because I know 2.28 is bigger than 1. It's bigger than 2. Right? Okay.
Now we have the 8/3, and we see that's way over 1.
Way over 1.
Yeah.
How many times does 3 go into 8?
2 times.
At least twice.
At least.
Almost 3 times, right? Because 9 over 3 is 3.
Yeah.
Is 8 over 3 closer to 3 or closer to 2? And if you don't know, that's okay.
Probably closer to 3.
Yeah, probably closer to 3 because it's going to go into 8 2 times completely.
And then it has to go in.
And then there's like 2/3 left.
Or the way around.
Yeah, it's closer to going into 9 than it is in going into 6.
Yeah.
You know what I'm saying?
Mm-hmm.
So it's probably closer to 3. If you're going to guess which one's bigger, which one is it?
Definitely it's gonna 3. I think it's getting bigger. Is what I see.
So which one's bigger, 8/3 or 2.28?
8/3.
8/3 is bigger.
Yeah.
Absolutely. Right. 8/3 is like, again, that's 2 2/3. Do you remember how to turn a mixed number into a fraction? Have you done that before?
Yeah, I have.
Yeah.
I think.
You multiply the 3 by the 2, that gives you 6, and then add the 6 to the 2, that gives you 8. 8/3. Those are the same. Right? And then what's bigger, 2 2/3 or 2.28?
2 2/3 is 2.
Yeah, the 2 2/3 is bigger.
Yeah.
So that's like 2.6666666 for infinity. And 2.28 is less than 2 1/3, 2 1/3, let alone 2 2/3. So we can confirm it is indeed answer choice A. But look, even if as far as you got was eliminating C and D, you still got a good shot at getting this problem. And it's still basic logic and basic estimation. Does that make sense, Jackson?
Yeah.
Good. Let's do one more. We'll do another least to greatest. Ooh, we're gonna have to talk about percents here. Actually, I tell you, we're gonna be coming into percents. Let's take a break right now. Okay, and we'll come back and work on that problem because we're gonna be doing a little bit of work with percents. You need to know how those work, and I don't want to interrupt that conversation about percents. So we'll take a 3-minute break. Is that cool with you?
Yeah.
You run to the restroom, grab some coffee, grab a soda, whatever you want to do, and I will see you back in about 3 minutes, okay?
Okay.
All right, see you soon, Jackson.